All right, hello everyone, and welcome to yet another webinar brought to you by PhoenixSnap and VMware. Today, we'll be talking about securing cloud environments through micro-segmentation. We'll be explaining how PhoenixSnap has partnered with VMware to include these capabilities in our data security cloud product offering. My name is Carl Camilleri, Cloud Services Product Manager at PhoenixSnap, and here with me today is Mr. Cheston Hay, Staff Cloud Solutions Architect at VMware. We shall be taking us for a technical overview around how VMware NSX handles micro-segmentation. Welcome, Cheston. Thank you for joining us today.
Thank you all for having me.
So as we proceed, before we get started with the rest of the slides, we'd like to present you with two poll questions that we wanted to relay today. And the first question shall help us better understand our audience and identify the industry you guys operate in. As you may understand, this helps us greatly shape this presentation to align with today's audience. And here are the number of industry verticals that we've made available for you to choose from today. So IT service providers and MSPs who are maintaining IT infrastructure for their customers, fintech or e-commerce organizations, healthcare, which are really crucial around compliance and security, SLED, state, local, or education entity, or whether organizations working in the ad tech industry. Give a couple of seconds for all answers to come in, and we'll be able to share that. All right, so we're quite solid on that result. Thank you so much. Before we kick this off, one last poll is to help us understand the crucial challenges that you guys may be facing currently or are looking at mitigating. Please go ahead and choose the one which fits best your solution. All right. That's also very clearly explained. All right. So as we proceed to the first slide that we have for you today in terms of the challenges and the data risks that we're currently facing, why are we here today? We're here today because since the last time we checked, these numbers being shown on your screens here have only increased. And what does that mean? That means that not only the risks are still there, but they have become more complicated and challenging to mitigate. Some industries are also being required to implement higher level of data security to comply with data protection regulations. For example, we see organizations that process payment card information. They must now use and store payment card data securely. Healthcare organizations in the US must secure private health information, PHI, in line with the HIPAA standard. But we all know that even if your organization is not subject to a regulation or a compliance standard or requirement, the idea behind the survival of the modern business that we know today truly depends on data security, right? This can impact both the organization's key assets and private data belonging to its customers. These numbers here, as you can see on the right-hand side, 90%. So these are number of reports in US and Canada of data breaches, typically from external sources, which had financial gain as the objective, the final objective. As we proceed in the following slides, we'll also be explaining how certain attacks and certain services are being now truly targeting these organizations. So what are the major cloud security challenges we're facing? So secure hybrid work environments. We all know that in certain situations, hybrid cloud offers the best of both worlds, right? The customizability, the flexibility of your local data center, coupled with the convenience of a cloud provider. But no matter what kind of setup we're employing today, organizations still need to adhere to a very important principle of the shared responsibility. So while the service provider offers security for the underlying infrastructure, or organizations are typically responsible for securing the data itself. So what does it mean? This means that implementing access policy and ensuring proper encryption and handling the overall configuration of the cloud service to fit the needs of the organization is the responsibility of the client hosting their workloads or infrastructure. So what we're saying is that the cloud providers will still go extra miles to help secure the workload, the environment, but we still want to make sure that our customers are doing proper implementations to secure their infrastructure and their workloads. Attack surface expansion, so some of the most common attack vectors, which include like phishing, weak passwords, insider threats, or even open ports. We need to always increase the level of risk factors that may be impacting our industry or our market. And these list factors have been increasing all the time, and we're trying to make sure that we help customers to mitigate these risks through tools that we'll be explaining further on today. Some ways that we're looking at mitigating this through identifying the physical and digital assets, or even revising asset management policies, or strengthening and securing vulnerable attack points, right, that we're all aware of. Another factor is crime as a service. There showed us item number 3 with some examples of such crimes, typically known as DDoS as a service attack or ransomware as a service attack. These would be someone who might develop a ransomware kit, right, that's capable of encrypting files where the victim would have to pay ransom for. Number 4, human error on employees going rogue. This is also one of the key elements that we're facing recently. We're trying to figure out how we can train and empower our employees and the users. But we all know that even if we implement the most robust security implementations, the risk of the human element still factors in, right, as one of the most crucial attacks. So move on to the next slide. Here we'll explain a little bit about how we're defining micro-segmentation. So the main concept of segmentation isn't new, right? For several years, we've been seeing organizations securing their perimeters through traditional firewalls, virtual LANs, access control lists. But with micro-segmentation, the difference lies in its level of granularity, we must say, right? Which allows us to integrate into the environment. Micro-segmentation was the latest step in the evolution of the traditional firewalls as we know it, and in the era of cloud-native containerized environments. But conceptually, micro-segmentation expands on the notion of traditional firewall DMZ, right, the demilitarized zone. And we enable this by establishing fine-grained segments that are isolating multiple firewalls. So what, as we can see here in this graphic, we're creating customized zones, customized perimeters around the resources that are most crucial to us, right? So whether that is a compute resource, whether that is a storage resource, we want to make sure that these workloads are even protected internally and within the environment, within the workload. And what does that mean? That means that we're decreasing lateral movement internally, right? We're decreasing the risk of having an attack which bounces on from one environment to the other. And through the level of micro-segmentation, we're securing specific workloads within our environment and within the data center facility. More about this will be explained shortly by Justin, who will explain a little bit more in detail how NSX handles all of this. So the main benefits of micro-segmentation. So as mentioned, with traditional firewalls and VLANs, segmentation would be typically split into blocks of resources. where then engineers would have to establish flows and communication between these segments, right? But in order for us to be able to make use of these four main benefits: reducing attack surface, improving breach containment, achieving zero trust security, and having more visibility into the hybrid environments, we have to undergo a certain set of policies that can only be achieved through micro-segmentation. Ideally, micro-segmentation should be the natural solution for cloud microservices environments, right? And considering that it's becoming the standard practice for DevSecOps, the advantage you get is basically a fine-grained control over all moving parts, right? And contain threats to the limited perimeter which is defined by your workload or your environment. This fine-grained control also allows us for better management and auditing of our systems. The idea behind micro-segmentation in terms of zero trust is to segregate and isolate the defined segments in an enterprise network and reducing the number of attack surfaces to limit lateral movement. As one of the main elements of zero trust, based on the NIST Zero Trust framework, micro-segmentation is crucial there in terms of securing IT infrastructure. So this has become a really popular way for us to control horizontal access within a corporate network or cloud. And we're also looking at how we can provide highly granular visibility and control over data flows within our organization's network. What does this mean? This means that to have a proper micro-segmentation solution, we need to accompany it with efficient and easy to use policy management, right? It's all about having the right policies in place. The policy management is also coupled through automation, which can help us implement and enforce policies with established defined parameters. One of the main advantages of micro-segmentation is to provide greater security for any network, but it also allows for a centralized management of flows and better auditing of the rules that are applied to the network environment. We'll be seeing how with VMware NSX technologies, we are making use of these software-defined capabilities for us to be able to create these zones and policy-based micro-segmentation tools for us to be able to make a clear understanding of how these workloads or how our environments are getting secured as we implement these structures. From here, I'll hand it over to Cheston, and he'll be able to help us visualize how VMware NSX technologies can enable us perform micro-segmentation. Over to you, Cheston. Thank you.
All right. Thank you, Carl. And thank you, everyone, for being here today. So again, my name is Cheston Hay. I'm a Staff Cloud Solutions Architect with VMware. So let's talk about some security with VMware NSX and micro-segmentation. So we look at this slide, starting at the bottom of this slide, you know, NSX security capabilities really focus on securing a diverse workload. Just because workloads are different nowadays, you know, we have a combination of virtual machines, containers, and physical servers. And then we also have a diverse deployment structure, because we see that people are doing things like multi-cloud. They still have their on-prem data centers that they manage. They have VMware-based clouds. And so we really excel into three different themes that we would say NSX security specializes in. One is being able to support a distributed architecture. So we're able to deliver security controls closest to the workloads, which is ideal in any kind of security posture. We want the security to be as close to the workload as possible. But then we're also service aware, meaning that because these workloads are running on top of an EXXI hypervisor, we're able to truly understand the application. And not only that, we're able to understand the context of that application. So things like the OS type, what type of processes are running, what type of vulnerabilities may be affecting that virtual machine. And because we have this level of context, we're better able to secure the environment and that application. And then finally, operationally, we're simple. I think as Carl mentioned, that's one of the things that we want to be able to do is make things simple. And because of that, we're able to provision firewalls, we're able to create security posture on demand. And we don't have to change anything with our physical infrastructure. We don't have to install any additional hardware, and we don't have to hardwire into any additional services that are there. And so the NSX security portfolio has truly grown over the years. I mean, it started out as just a firewall, a L2, L7 stateful firewall, but now it has grown to so much more. We've advanced, we have more advanced solutions integrated like threat protection. There's our IDS, IPS services, network sandboxing with the ability to help us identify malware and to protect against that. There's also behavior-based network traffic analytics by means of network insight and NSX intelligence. And then too, one of our later acquisitions of Carbon Black that are providing endpoint security. So we truly see how the NSX security portfolio has grown over the years. And there we go, there's the next slide. And so let's talk about how much our applications have changed throughout the years. You know, it used to be a lot easier to secure an app back when things were more in a monolithic stack. And what I mean is there was more so a one-to-one relationship between an application and a server. And even in cases where there may have been multiple servers that made up an app, for the most part, they still live within the same data center and sometimes even in the same rack. And so it was easy to maybe stick a firewall at the top of that rack and make a nice perimeter around the application. But that's completely different today. Today, our applications are very distributed. They may be compromised to many servers or even containers for that matter. And not only that, they're possibly hosted on multiple data centers or even multiple clouds. And so these data centers and these clouds, they are changing constantly, particularly when we think about how developers are starting to embrace DevOps and other new technologies like containers and microservices. So although it makes them more agile, you know, it definitely increases the speed in which we put applications and data in the hands of our users. But at the same time, they can present a true challenge when it comes to security. And so let's see, we can move on to the next slide here. There we go. Oh, let me go back one. I think it's going back to the right slide. Well, there we go. So what we're trying to do when it comes to security is really to shrink the attack surface. And we do that more so by not bolting on any additional solutions, but really trying to make security an intrinsic part of the infrastructure from where we have our apps and data to. But I'll just talk through this part. But what we really want to do is be agile. So we want to still meet the demands and needs for providing data at speed, but we still want to maintain our standards of security. And so that's the whole idea of what NSX is it's built-in security, not bolted on security. And so that's really where we want to architect security in our environments. So when it comes to the distributed firewall in itself, you don't take away anything else from this presentation. Take away the fact of these 5 things that you should know about the distributed firewall. One, it does not require any physical network changes. So don't have to make any disruptions to your network in order to implement the distributed firewall. Also, it's flexible in that it can work with both physical servers as well as EXXI and KVM hypervisors. It is a true stateful firewall, L2 to L7. And we do provide east-west visibility to really kind of prevent those lateral movements, which we'll talk about, preventing lateral movement of security breaches. And then again, we talked about being operationally simplistic. And so being able to manage all of this within a single pane of glass, to be able to manage our firewall rules from a single pane of glass across all of our sites. And then, of course, being able to provide both macro segmentation and micro segmentation services. So these are all key identifying marks of the distributed firewall that we want to take away. And so now we want to kind of transition to talking about the architecture of what the distributed firewall looks like in relation to NSX security. So what you're seeing here is a high-level overview of the management and control planes and how they relate to the DFW. Now, you configure your policies there at the top at the NSX manager. And that's where the validation is performed. That's where your firewall configurations are stored. So things like your rules, your sections, your grouping objects, all of that is stored in our NSX manager. Then that policy is pushed down to the control plane. Now, different from NSXV, where the control plane was separated, NSX-T encompasses both the management and control plane. So that's what you notice there at the top. But once those controllers take those rules, they convert them into the objects that are necessary to define the rules, and then those are pushed down to our hypervisors. And what I want to illustrate again here is that with NSX-T, the configuration push is done from the management plane through the central control plane, and then it's pushed to our what we call transport nodes or our hypervisors. And so that's what you see at the bottom. Here at the bottom, you see 4 hypervisors in which they have their own local control plane, or LCP, that receives the DFW configurations from the central control plane from our NSX managers. And so this is a local process that runs in, and then it pushes the information down into the actual kernel of the hypervisor nodes. And so now we want to kind of focus a little bit closer on what that data plane looks like from the transport node. So just kind of defining what that transport node is. A transport node is essentially a hypervisor host that has been prepped for NSX or had the NSX VIBs installed on them. So the NSX-T transport nodes, they make the distributed data plane, as it were, because we have multiple hosts in a cluster, and yet that data plane is existing on each one of those hosts. But it allows for DFW enforcement to be done at the hypervisor kernel level. And so each one of these transport nodes at any given time, they'll be connected to one of the central control plane clusters in our NSX manager cluster. And so on each one of our transport nodes, you'll notice that little green LCP box. That's the local control plane for that particular node. And so that's where the policy configurations are pushed down from the central control plane. That's where our firewall policies exist. That's where the rules will be filtered to, and then they'll be filtered down into the kernel onto every single virtual NIC that is on that host. So every single VM essentially has its own firewall attached to it. And then when we start using our rules, especially our apply to section field on our rules, that's where we kind of define our scope of what we want to enforce or how we want to enforce our actual rules. And so the LCP makes sure that only relevant DFW rules are programmed on relevant virtual NICs on that host. And I'll show you an example of that later in a slide where what this apply to section is all about is making sure that we're effectively and efficiently placing our rules on hosts only where they're needed at. And so, of course, we also talked about, flexibility. So not only do we support EXXI hosts as, transport nodes, but we also support KVM hosts. So on the next slide, here we see an example of a KVM host. Now, NSX-T provides network virtualization and security services for them as well. And so functionally, the DFW works identical on both flavors of hypervisors. But there is a slight difference in the data plane implementation of those because they use different type of virtual switches. So on the KVM host, there's an NSX agent that is the primary local control plane component for those hosts. And so that NSX agent receives the DFW configurations from the central control plane. And so that NSX agent has the DFW wiring modules as part of its component. And it generates open flow traffic flows based on the firewall rules that were pushed from the control plane. And so it provides stateless filtering, and it implements this through the OVS daemon, which is part of the Open vSwitch, which we see at the bottom. And so it's able to configure the rules that it receives from the local control plane in the form of open flows. And then the Linux contract utilities are used to keep track of any connection states that should be allowed or disallowed based on what the firewall rule is set to. So as we move forward, we talked about the distributed firewall rule, the distributed firewall, and being able to prevent lateral spreads across an environment. And so really the mass majority of attacks that breach the perimeter today are really compromising just one single machine. And more often than not, the attackers are really exploiting a human being. You know, it's not the technology itself sometimes that fails us, but sometimes we're our own worst enemy. When we see things like phishing emails, social engineering attacks, you know, these are not high-tech attacks, but they are extremely effective because they prey on human mistake. And so once that attacker goes and gets inside the perimeter, once they breach it, it's a lot easier for them to move laterally throughout the data center from machine to machine. And so at that point, they find the information that they want to steal or the information that they want to hold for ransom. And so that's where the power of the distributed firewall comes in. Because we do define and enforce network policies on every individual workload in the environment, we can help to prevent that. You know, so when we think about the level of effort that it would take to do something like this with physical or virtual appliances, it can be very expensive. And not only that, in most cases, it can be operationally just infeasible. The amount of rules that you would have to manage alone would turn many people away from even trying to implement something like this. But with NSX, it allows us to design and manage all of these policies from a central location. It's all software defined, so that makes it agile. But then too, we can automate a lot of this. So that's a key component about the NSX firewall that's unique. We're able to use things like security groups and tags from vSphere to help us orchestrate the creation of our policies. And then because we have these tags or security groups, any additional applications or VMs that we need to make a part of those groups, they dynamically inherit any of the security policies. So it really makes management overhead a lot lower because you're not having to create a new rule just because you add a new workload, a part of this application. As long as it's a part of that group, it inherits everything that the other VMs have as well. So when it comes to just securing our apps, how do we actually do that with micro-segmentation? Well, first we need to understand the application. We can't secure it if we don't understand it. So we need to be able to determine which VMs are compromised or make up our applications. And so once we do that, then we need to find out what traffic is actually necessary in order for that app to function. So once we understand our application's composition, the necessary traffic, then we can start to create our micro-segmentation policies. And so this immediately, once we do that, reduces the attack surface of the application because we're limiting our communication to only what is absolutely needed for that application. But now, we don't want to be too restricted because there are still legitimate, maybe additional services that need to access our application. Maybe AD services for user authentication, or maybe it's another application that needs to talk between application tiers. Well, how do we continue to account for that, but at the same time making sure that we direct any threats away from the application? Well, that's why being able to understand the application's composition is really important, because once we understand the application, the makeup, and we make up those micro-segmentation policies, then we're able to restrict that unwanted network traffic. So again, we talked about reducing the surface of the attack. Well, once we establish our intended state for our workload, what processes should be running, what OSs should be configured, what patch levels should be there, then we're able to lock that application down. We're able to understand what its intended state should be, and then we can have our rules set exactly for that. So when it comes to actual constructs of what our rules look like, really to any person that's ever managed a firewall before in their life, it should feel kind of right at home, because it's very intuitive, it's very simple to understand what you're configuring as you're making these rules. So as simple as creating your rule identifier or a title for it, understanding what services you want to allow or disallow. And so we do have the normal predefined services that many applications use. But in the event that something doesn't provide you the ports or the access that you need, we can create custom services or service groups where we can group multiple ports together and allow that to be used as part of our services to allow or deny. And of course, we have the normal actions of allow, deny, reject. And then, of course, we can also set the direction in which we want to enforce our policies as well. But now this is what I was talking about earlier when I was talking about our applied to section. So the applied to section is where we really get granular with our firewall policies. So by default, you'll notice there in the applied to section, you see DFW. By default, all rules are set up as applying to the entire distributed firewall. But now that's not always the most efficient way to do things. We want to be more granular and only place rules where they need to be. And so the supply to section really helps us define our scope. So there we can optimize our resources. We can group the VMs together that only need to have those rules applied to them. And what that'll do is that'll make sure that where those VMs exist, that is the only place that those rules will exist. And so in this next slide, you'll kind of see an example of that. You'll see an example of where the rules were first applied to the entire DFW. And because of that, it's an inefficient use of resources. We have additional rules there that we don't need. And just like any other stateful firewall, it's going to go down the entire list until it finds a rule that applies to the app or the VMs that it's going against. And so that's using the resources that we don't necessarily have to use. But when we make sure that we use our apply to section in the proper way, and we actually set it to a group or a section of VMs, notice how we reduce the footprint of the rules that are allowed on that host. Because as we mentioned earlier, it understands the connection states, it understands every virtual NIC that is on that particular host. And so as those virtual machines move around, those rules move around with the virtual machine. So only the necessary rules for that particular host based on the workloads that are running on it will be on that particular host. And so now let's move on and talk about another thing when it comes to the NSX firewall. Again, it's flexible. So we support a number of different deployment scenarios. So of course we were talking about traditional VLAN workloads. We support that. The DFW can support NSX managed VLAN workloads as well as physical servers. Of course, we can also support our overlay-based NSX workloads. Those are our traditional logical switches that we're used to. But then we also have the concept of what we call a service interface. And what that allows us to do is provide gateway and inter VLAN firewalling, even for non-NSX managed workloads. And so what we will do is on our T0 or T1, we create a one-to-one mapping between a service interface and a VLAN that we want to provide firewall services to. And then finally, we support doing bridging between overlay segments that are managed by NSX and non-NSX VLAN-based workloads. And so again, we talked about NSX being simple. And if you want to use just the DFW portion of NSX, it really is a simple process to integrate it even in an existing environment. Because of the fact that we're not using any routing services, we're not needing any tunnel endpoints for decapsulation of our Geneve tunnels, we can just prep the host for NSX and not deploy these other pieces. And so that saves resources, but then it also just makes it simple for us to actually get started with using the distributed firewall. And so this next slide really just shows lets you know that we do have a simple, easy to follow step-by-step implementation guide when it comes to getting the firewall enabled. And so it really is kind of boiled down into four simple steps. So if we go look at our next slide, prepping our cluster, all that means is that we are installing our NSX VMs onto our host, and those become our transport nodes. Then we actually create our segments, which in this case, we'll be talking about maybe our VLAN segments. And then we move our VMs onto those segments. And so when we're talking about moving here, we're not talking about any physical moves. Any VI admin knows that we're talking about just simply going and editing the setting on our NIC and changing it from the distributed port group that is on and selecting the newly created VLAN segment from NSX. And then from there, those VMs are there and they're able to start inheriting the policies that we begin to write for them. And so we talked about today, truly we talked about just the adaptive firewall and micro-segmentation capabilities of NSX, but it can do so much more. No, Carl mentioned about creating like a DMZ in software. We essentially can create a DMZ for every VM if that was the case. But really, truly, there are several other use cases that we have for NSX security. What I want to point out is that not only does NSX deliver an enormous amount of value in itself, but it also increases the value of other existing solutions. You know, to have a true platform is also good to have a true good third-party ecosystem as well. And NSX has a rich ecosystem of partners that spread across physical to virtual, operations and visibility, security services. And so all these different partners are able to integrate into our platforms and provide additional services. And so finally, you know, if you want to learn more about the distributed firewall and NSX, we have, you know, several resources. We have our VMUG sites, we have our hands-on labs. And if you want to take your knowledge to the next level, then we have our NSX trainings and certification tests as well. So that's it. That's all I have there. Any questions, feel free to type them in the chat and I'll monitor those and answer them as I see them. So thanks.
And thank you so much, Justin, for that. Intuitive, one must say, feature set that NSX is providing, even with the new release of NSX-T. So as Phoenix Snap, what's our main goal, right? Our main goal is that with DSC, our data security cloud multi-tenant product offering, is to continue providing enterprise-grade security technologies, right? Which will make it easier to businesses to have the right resources and facilitate the level of security that they need through these environments and through a cloud deployment. What we're doing with Data Security Cloud, we're basically baking in a number of solutions, a number of technologies that is helping us shape the right product for organizations who are looking to mitigate and achieve the highest security measures. So in a nutshell here, what we're seeing is the infrastructure that we use with our partners Intel, specifically SGX technologies to enable encryption. We're making use of, as Justin was explaining, VMware NSX. This is bread and butter for our product. We are managing both the networking part, the security part of this product. And we're also leveraging VMware's Cloud Director, which enables you IT service providers to manage the environments and workloads of your customers. So in a nutshell, the idea behind Data Security Cloud was to collaborate with technology industry leaders in providing a multi-layered security with strict security and compliance goals, right? So through the ability for you to deploy micro-segmentation, having endpoint protection and threat intelligence, and even MDR technologies from Alert Logic, which mitigates managed detection and response, we're able to have a very abrupt product to our customers in terms of software-defined data center. One thing here good to mention as well, we're also including Veeam backups as part of the product, which we can explain in the next slide coming here. So the benefits of this product is the hardware reliability that we provide through Intel-based processors, through the state-of-the-art security, both in terms of the perimeter of the data center facility that we support, but also in terms of providing the right tools for our customers to help secure their workloads. No complexities in terms of the way that we sell this product. We sell this product by the number of resources. So basically it's consumed of number of vCPUs, number of VRAM, and a cost-efficient deployment where we are being very competitive in the market, considering all the feature sets and the technologies that we're baking in this product. So for us, the main benefit of some of the features and plans that we're including with this product, as you can see, the VMware NSX powered network segmentation, which is not only available in the SC Essentials, but is also available in the SC Essentials side. But in a nutshell, this is what you get, right? We're getting antivirus scanning, we're getting security posture reports, we're getting a threat risk intelligence, we're getting 50% of the data backed up with the SC Essentials. We're protecting 100% of the data with the DSC Advanced. And recently, we also introduced HSM-grade encryption key management platform through our partnership with Fortanix. Basically, what we're referring here is, and I'll also leave a couple of minutes for any questions after this or any statements that you might have, but basically what we've partnered with VMware with basically for the reason to elevate the technologies and the features that VMware has invested along the time, couple it with our infrastructure as a service portfolio of products, and be able to provide you with a solution which helps enable you to host workloads and mitigate all the security risks that we've mentioned earlier in this presentation. We also couple VMware Disaster Recovery as a Service technologies with our product, and as well provide backup technologies through our partnership with Veeam, which most of you in the MSP space are very much already familiar with. All right, so as soon as we wrap up the presentation we have today, I'd like to give some space to any questions that you may have for Justin or for myself in the questions section that should be enabled for you in the control panel. So we'll wait for a couple of questions to come in so we can explain. All right, so it seems like we have one question from Will. How will communication between segmented workloads affect the performance of our systems? Okay, so very good question. So the as Justin was saying, there needs to be a very good understanding of the current way the traffic is being utilized through our workloads. There are several ways, right, to minimize the risk of blocking legitimate traffic, which actually is affecting the performance, or even blocking flows that are requirement for your environment. And one way to make sure trusted flows or traffic does not get impacted. We generally recommend customers to perform a thorough discovery process whereby such legit traffic and communication is discovered. And one may also utilize logging collectors, right, to be able to understand the certain logs that are existing in your workloads while you're conducting this documentation procedure. Once we have that in place, we are allowing, through a policy of rule, depending on the setup, the idea of perimeter zones and policy-based structures, right? So for us to be able to refrain from actually affecting the existing performance of our systems, we need to make sure to have a good understanding of our placement, right? We need to have an understanding of how the traffic is flowing, which workloads need to communicate with other workloads, so on and so forth. So I hope that that question was answered correctly. All right, I think we can take another question here. How is it to create and generate firewall policies? Is that something you do for us, or are we left to our own device to create segmentation rules? So as a cloud service provider, we're making sure to safeguard customers, right, with our own security policies, which protect our data center facility. But for our customers to enable their own macro and micro segmentation capabilities, we're providing them these tools, these NSX tools and capabilities, so that they can implement and use these policies to segment compute and data resources as needed. Now, considering that to perform these implementations, as it has been suggested earlier, one has to fully understand the existing workloads and having a good grasp of the data traffic. It is typically our customers who would need to undergo this process, right, to implement the right policies and rules. Each customer, each organization have different requirements. They have different sets of architecture and the way they have even created their environments. So this greatly impacts the way our customers are today leveraging the areas around NSX and what brings with it in terms of micro-segmentation. So I hope that was clarified as well. And thank you for your questions. Not sure if we have any other questions coming in. Please feel free to drop them in. As a final poll before we wrap up, please feel free to answer this poll if you wish to learn more about this topic and perhaps assist you in helping securing your workloads. We have a dedicated sales engineering team as well, which is able to understand your requirements, which is able to help shape some of the security requirements that you need through compliance or your regulations. And also they're very deeply versed into NSX and micro-segmentation as well. So that's a great value that we provide to customers in terms of part of our support, even before coming our customers. So that's something we're proud of, to make sure we handhold our customers in their plan of moving forward with utilizing a cloud service provider like Phoenix. Once again, thank you all for staying with us today, and I look forward to hearing from you soon, and have a good rest of your day. Thank you so much.